All right, welcome to class, everybody. It's good to see all of you guys. So this week we are moving on from the torso and we are moving into the shoulder and elbow joints. So these, to me at least, these start to get a little bit easier in terms of kind of starting to guess what these muscles are doing. We've had pretty good practice by this point, right? Front muscles flex, back muscles extend. So here we're moving to a new joint, but the basic premises is going to be the same as what we've been seeing before. So quick recap of the major features in the area, just to refresh us of what's going on here. Major bones, scapula, humerus, radius, ulna. Scapula, the only two new landmarks that I want to bring our attention to that we haven't been dealing with already before are the supra and infraglenoid tubercles. We will recall those are two small bumps on the superior and inferior aspect of the glenoid fossa. That is the socket where the head of the humerus attaches. So just above and just below are two small bumps, both of which will have muscles attaching to them. Humerus, we've got the head, greater, lesser tubercles, we're good. Intertubercular groove, we recall that one. Medial and lateral epicondyles. If you bend your elbow, you'll find three bony prominences, one on the medial side. If you have to guess, that's the one. The big bony bump on the middle side, medial epicondyle. Then we have the olecranon process of the ulna. So your proper elbow, this is actually the ulna. And then the lateral epicondyle will be the next kind of bony bump that you'll feel. And then superior or proximal to both of those epicondyles are the medial and lateral supracondylar ridges. Push your thumb in, run in a transverse direction, you will feel a sharp, bony ridge running in this direction. That's the one. Nice pictures. Radius. The radius is on the thumb side in anatomical position. And I keep this straight in my head because the radius is rad. It's on the thumb side. If you think about your great aunt Ulna, little nice Miss Prim and Proper, when she drinks her tea, she has her pinky out like a lady. The ulna is on the pinky side. So think of your proper auntie Ulna sipping her tea all proper, and the radius is rad. Cool. All right, a few ligaments. The annular ligament runs around the head of the radius. It just keeps the radius locked in place. Radial collateral ligament runs from the humerus to the radius. The ulnar collateral ligament runs from the humerus to the ulna. So kind of like parentheses or brackets, they just lock those two bones together on the sides. And then you have the bicipital fascia. I'll pull up our little anatomy guy. When we talk about the bicipital fascia, we're usually getting at this, the bicipital aponeurosis. It's aponeurosis is a flat tendinous sheath. So it's a tendon, it's just shaped like a flat sheet of paper instead of, like if you look in the wrist, being shaped like strings or ropes. All we're looking at is a difference in the shape, but this is just another structure that we want to be aware it does exist. So, beautiful landmarks. We only have an hour in kinesiology to get to the muscles. So if bones and bony landmarks, if we're a little rusty, get at me in class. I will set aside some time and we will grab some bones. Bones are my thing. All right, major joints. Biggest joint we're dealing with is probably the elbow. The elbow specifically is the humeroradial joint, the joint between the humerus and the radius. That's not right. Humeroulnar. So, yeah, I was like, no, that's not right. Humeroulnar. Between the humerus and the ulna, that's a hinge joint. This joint only moves in one plane. It closes, it opens. Kaput, that's it, the end. Roll credits. The radioulnar, or the The radio-ulnar joint between your two forearm bones, that is a pivot joint. So these two bones will rotate relative to one another. And the key point here, guys, is the radius is the one that moves. The radius rotates in place relative to the ulna. The ulna doesn't move relative to the radius. We've talked about nerves, again, the major nerves that run through the area. The ulnar nerve is the one that you can feel on the elbow. That's your funny bone, right? When you pluck that little string and it does not feel good, that is going to be the ulnar nerve. The median nerve is the one implicated in carpal tunnel. It innervates this portion of the hand, and then the radial nerve innervates the posterior side of the hand. So elbow conditions, most common conditions, these are both chronic injuries. So it's not like, oh, I fell and broke my elbow. It's I've been playing tennis all of a sudden, and now like my elbow really hurts. We have medial epicondylitis and lateral epicondylitis. These are inflammations of all the muscles that attach to the medial epicondyle. Specifically, these would be all of the flexor muscles of the wrist. And then the lateral epicondyle is all of the extensor muscles of the wrist. They all kind of originate on that same spot. Lateral epicondylitis is called tennis elbow, right? The extensors with the backhand of a tennis racket, it's lots of this kind of action, right? You come in and hit the ball that way. Lateral epicondylitis is tennis elbow. Medial epicondylitis is golfer's elbow, because they come in with all of their flexors and swipe the ball that way. Again, these are inflammatory conditions where the pain and inflammation is generally focused on one side or the other. They don't necessarily have to be playing tennis or golf. The condition is just called golfer's elbow. So you can get golfer's elbow from like doing a lot of different things. I'm just saying. All right. We also should be pretty good with movements of the shoulder by this point, right? We have flexion, we have extension, we have abduction. With the elbow, we have flexion, we have extension, and we also have pronation and supination. The way I like to keep these straight, imagine holding a bowl of soup. That is supination, turning the palm upward. Hold the bowl of soup, pour it out, pronation. You could also think, you could draw a little smiley face on the palm of your hand and have your client is supine, face up, or your client is prone, face down. Either way. All right, so we have several muscles to cover today. I believe there's 8 muscles that we're going to get through today. Any questions so far? Temperature check, everybody good so far before we dive in? Cool, cool. All righty. Finally, the biceps. I feel like we've only been putting this muscle off for so long. Before we jump into bicep, I want us to take a good look at this muscle. The name is telling you something. Bicep means 2 heads. So the biceps brachii is a 2-headed muscle, meaning it has 2 distinct origins, but 1 distinct insertion. The last name brachii tells you the neighborhood this muscle grew up in. It's in the brachial region of the arm. This will distinguish it from my peeps from back in Kines lowers. You'll remember the biceps femoris, which is another 2-headed muscle, but this one's on the femur instead of the humerus. So looking at this muscle, it crosses the shoulder and it crosses the elbow. So it moves the shoulder and it moves the elbow. Both instances, it's crossing the joint on the front side, on the anterior side. So that's going to make it a shoulder flexor and an elbow flexor. Since this muscle also inserts more on that medial aspect of the radius, when the muscle contracts, it will pull up on the medial aspect of the radius, causing the radius to rotate laterally. This will result in supination. So the biceps brachii is a supinator of the forearm as well. So here we have the long head of the bicep is the one that's going to take the long way around. It wraps around laterally, resting in the bicipital groove or the intertubercular groove. Let me switch this back up here so we'll see. It's the long head tendon rests in the intertubercular groove. It attaches to the supraglenoid tubercle. Oops. Come on, thing. Oh, sorry.
That's not the one that's highlighted, right?
No,
Okay.
it's not. I was trying to get there. It wasn't cooperating with me. There we go. Long head. It sits a little more lateral on the head of the humerus. It rests between the lesser and greater tubercles, right in the intertubercular groove. It wraps across the shoulder and starts on the supraglenoid tubercle. It's called the long head, by the way, because if you take those two and lay them out on a table, it's a little bit longer. The short head, which is the one that is not highlighted, originates on the coracoid process. So now that we have said this, red alert. Everybody needs to stop for a second. Somewhere in your notes, you just have something very important that we just learned. We have now covered 3 different muscles, all of which attached to the coracoid process. That's a test question if I ever heard one. There should be alarm bells going off in your head when you've just heard multiple muscles that are sharing that same bony landmark. Who can tell me the 3 muscles that all attach to the coracoid process, not including bicep because we just said it?
Coracobrachialis.
Pectoralis minor.
Pec minor. Yeah.
Pectoralis minor, coracobrachialis, and bicep brachii. Those are always going to be test questions, my friends. Well, welcome to kinesiology. So you may see it written, which of these muscles does not attach to the coracoid process? Or you may see something like, all of these muscles share an insertion point except, and then you'll have a bunch of muscles listed. Anytime multiple muscles share the same insertion point, make sure you know every muscle that attaches there. That's going to be a test question. So, supraglenoid tubercle of the scapula, coracoid process of the scapula, insertion, radial tuberosity. Its actions we've already deduced. It's a shoulder flexor, it's an elbow flexor, and it's going to be a forearm supinator. Forearm supinator. Also, I would like us to make a quick mental note. When we think of the biceps brachii, most of us, if I say, show me your biceps, we're gonna go, yeah, show me your guns, right? Or my squirt guns, in my case. As much as we think of the biceps being right here, they do not attach to the humerus. They don't attach to the humerus at all. Just a fun fact. They run from the scapula to the radius. Now, biceps' best friend is brachialis. I want to say best friend. I'm going to say more like wingman. You know, when you go to a bar, you want to have like your hype man, someone who's going to like talk you up for the ladies. You know what I'm saying? You want to have someone who's like in your corner. Brachialis is the wingman for the biceps, because if you really want your biceps to pop, you really want them to stick up in that nice rounded, you've got to have a developed brachialis, which sits just deep to the biceps. So let's take a gander at this guy. When we turn to the lateral view, there is brachialis, just deep to the biceps. So you can imagine when you're flexing, if you want those biceps to really pop up, brachialis underneath also needs to be really well developed to lift up on those muscles. Looking at brachialis, first thing I notice, it starts on the humerus, it crosses the elbow, it inserts onto the ulna, it crossed the elbow on the anterior side. That makes it an elbow flexor. It doesn't cross the shoulder, so it cannot move the shoulder. Elbow flexion, that's what this muscle does. So its origin is on the distal half of the anterior surface of the humerus. It is attaching all along the shaft of the humerus. The entire distal anterior half of the humerus crosses the elbow. Its insertion point is going to be the coronoid process and the tuberosity of the ulna. It's one action, flexion of the elbow. All right. Next muscle, brachioradialis. For best results, say it with a Scottish accent. It's the brachioradialis. It's your beer drinking muscle. You want to see this muscle? You can really see it. Any beer drinkers in the house? Make a fist like you're about to pound a beer. Now, put your hand down on top of your fist, and now push the fist up into your hand and look at your forearm. You will notice a very distinctive round muscle suddenly appear right about there. Maybe if you're sitting at a desk, give me a second, if you're sitting at a desk and you have a table, I'm gonna lower my thing now. Put your fist under the desk, push your fist up towards the ceiling, and there is brachioradialis. It's the very evident muscle that appears when you flex the elbow against resistance on the forearm. Brachioradialis. That's your beer drinking muscle, laddies. So brachioradialis starts on the proximal 2/3 of the lateral supracondylar ridge of the humerus. So right about up here, just above the elbow, inserts at the styloid process of the radius, which is going to be way down here by the base of your thumb. That's a very long muscle. So here we have brachioradialis. It starts on the humerus. It crosses the elbow on the anterior side. That tells me elbow flexor. It runs all the way down. We're going to zoom way in. There is its insertion on the styloid process of the radius. So it does not cross the wrist. It only crossed the elbow. So that's the only joint that this thing is going to move. It inserts on the humerus. So as your wrist moves up and down, that insertion doesn't move. It does not move the wrist. So since it crosses the elbow on the anterior side, its primary action is going to be elbow flexion. It will pull the end of the radius towards, well, the scapula. That's going to assist with flexion. But when we put resistance against the hand, like let's say like a doorknob. It will also assist with forearm supination or pronation when there's resistance. I would like for us to really think about this muscle though. It's primarily an elbow flexor. That's its main job.
Hey, Dave.
Yes.
I totally understand what supination and pronation is. Like, I get that, but I don't see how that happens. Like,
So the radius rotates medially, which will cause a pronation. Now the bicep contracts, pulls it laterally, creating a supination. The radius is rotating in place. If you look at the ulna does not move. It's only the radius. So the radius is essentially going to have to be rotated laterally or medially, depending on how a muscle is inserting.
okay, and so this is the biceps that you're showing us. So it wraps
Yes.
around it. It's like all like tangled up down there.
So I want to point something out. It appears that muscle that's wrapped around, that's a different muscle. That's not the bicep.
Oh, okay.
Yeah, that muscle is anconius, I believe. You'll see where the bicep attaches. There.
Okay.
Yeah, the other muscle that was on there was anconius. We're gonna get to that one later today, but that's the muscle that you were seeing earlier, supinator muscle. Is that a little bit better?
Yeah, thank you.
Yeah.
Can we see a pronation muscle? Like maybe brachioradialis? I don't know.
How about pronator? It pronates.
Oh.
So you're looking at a right arm. So where this muscle originates is the medial epicondyle. When the muscle contracts, it's going to pull the radius into a medial rotation. Remember, in anatomical position, a medial rotation is going to turn the palm backwards. That's pronation. And so now I need a different muscle like the bicep to pull from the other angle, right? From a more lateral angle. Now we create a lateral rotation, rotating the palm forward. Good stuff, everybody? Good stuff, clear? I love brachioradialis. It's a cool one. It's a fun one. Fun to show off in a bar too. All right, the triceps brachii. Tricep tells me 3 heads. Right? Brachii tells me it's going to be on the arm. We probably are just in general, we're probably aware of our triceps, right? Triceps are the only muscle on the posterior arm. Anything on the posterior arm, it's triceps. So with a name like tricep, we have 3 origins. We only have 1 insertion. Let's look at this muscle. There are your triceps. And you may say, wait, Dave, I only see 2. Good. Yes, there you see 2 of them. The third is deep to all of those. So we'll get there. We'll start with the top one. The long head originates on the infraglenoid tubercle of the scapula. Then we have another that begins on the proximal shaft of the humerus itself. The third head is here. It is completely deep to the other head. So it's also originating all along the posterior shaft of the humerus. All three heads converge into a single tendon, which crosses the elbow and inserts onto the olecranon process of the ulna. So the triceps crosses the shoulder and the elbow, both on the posterior side. So the triceps is a shoulder extensor and an elbow extensor. So the bicep flexes, the tricep extends. The bicep will flex the elbow, the tricep pulls on the olecranon and pulls the forearm into extension. Since we have a muscle that is inserting medially, right? We've got the triceps starting on the humerus and its origin was on the scapula. Muscles that insert medially are adductors. So that one head of the tricep that started on the scapula, once we are abducted, long head of the tricep will help pull us into adduction. So extension of the shoulder, adduction of the shoulder, extension of the elbow. Those are your tricep movements. This app only shows extension for the, oh, you know what? That's because I clicked on the certain head. Let me see if I can. There we go. We've got shoulder extension. All right. So we bring the shoulder into flexion and then the tricep contracts and brings us back. And then it contracts a second time. That brings us into hyperextension. Elbow extension. Once we are flexed, the tricep contracts, the elbow straightens. And what I also like about this app is as the elbow flexes, you can look at the triceps lengthening. So they shorten when they do their action, then they lengthen, and then they shorten again. Just a little detail. All right. Next muscle is anconeus. Unfortunately, the name doesn't tell us much of anything, so I can't really kind of use the name to figure anything out about it. Anconeus begins on the posterior lateral epicondyle of the humerus. Posterior lateral condyle of the humerus, insertion, olecranon process, kind of the posterior side of the ulna. Because this muscle crosses the posterior side of the joint, it's going to be an extensor. Now I know that it runs at an angle. It may assist with, nope, that's it. I know it runs at an angle. We just have to die mad about this one. It's just an extensor. Has everybody heard of this muscle before? Is this your first time hearing about the anconeus muscle? Oh, super. Yeah, because I'm kind of at a loss. I'm like, what else do I say about this guy?
What does Anconius mean?
That is a fantastic question. Who has a trail guide handy? I don't have my trail guide. Yeah, Amelia's got hers. This will be on page 139 of your trail guide. And when you get to the bottom of when you get to page 139, it should be in really small writing at the very, very bottom of the page.
It says Anconius is Greek for elbow.
Womp womp. Darn you, Greeks. Couldn't have been a little more descriptive. All right. Well, there you have it. Sorry, guys. Anconius, it means elbow. It's in the elbow. What does it do? Extends the elbow. All right. Next up, the muscle supinator. Now, this one's cool because guess what the supinator does? Anybody? Anybody? Does it supinate? Yeah, it does. Good guess. Good guess. See, those Greeks knew what they were doing. Sometimes they smoked a lot of opium back in the day. So, all right, supinator muscle. Origin. Ugh, I gotta get rid of that note. It's messing up my feng shui, man. There. So supinator was the one we saw earlier that was like wrapped around the radius. Yeah. So with a name like supinator, supinates. That's what it does. Starts on the humerus and on the ulna. We got those distinctive kind of V-shaped fibers. But it wraps around the shaft of the humerus to insert kind of the aspects of the radius, kind of like the proximal, anterior, and lateral sides. This is not official, but you could think of it inserting at the radial tuberosity. So it starts on the posterior lateral shoulder and wraps around to the medial side of the radius. So you can imagine when it contracts, it's going to cause the radius to rotate laterally. A lateral rotation is supination. A lateral rotation of the radius. Be specific. And here we have it. So we pronate, and then we supinate. And now we pronate, and then we supinate. You also spot bicep. Bicep is also shortening when we supinate because biceps is a supinator. So while we're pronating, bicep and supinator muscle are lengthening. I just love this stuff, don't you? Supinator crest of the ulna, lateral epicondyle of the humerus. Well, come on, screenshot, catch up. There we go. Radial collateral ligament of the elbow, annular ligament of the radius. It's just attached all here. It's just all in here on the lateral side. Insertion, anterior, proximal, and lateral surface of the radius. Its action, forearm supination. With a name like supinator, it's probably only going to do one thing, right? It's like Green Arrow. Huh, wonder what he's going to bring. Oh, arrows. Shocker. Next muscle we have is pronator teres. Now with a name like pronator, it pronates. But this guy will also do a little bit of flexion. So here is pronator teres. Simple, unassuming, humble little muscle. Starts on the medial epicondyle of the humerus, right along the supracondylar ridge, cuts diagonally across the elbow on the front side. So number one, flexor, because it's on the front. And because it runs at an angle, it's going to rotate something. It's going to rotate the radius medially. When it contracts, it's going to pull the radius medially. That is going to bring us into pronation, hence its name. And there you have it, folks. So this guy pronates, then supinator and bicep brachii supinate. Again, the ulna does not move. The ulna is not part of this joint. Now, medial epicondyle and coronoid process of the ulna, insertion middle of the lateral radius. So when it contracts, we have forearm pronation, and it did cross the front, so it is going to be an elbow flexor. So pronator quadratus. This is going to be a muscle that also pronates. Quadratus tells me I'm looking for kind of a rectangular shaped muscle, something shaped like a square or a rectangle. So as I just start to cut muscles away, oh, where'd you go? I'm not hunting you down. Bam. Oh, that was down the wrist. That's fine. So pronator quadratus originates on the ulna, because remember the ulna doesn't move. Origins are always going to be on the least movable side. Inserts on the anterior aspect of the distal, I would say like quarter, 25% or so of the radius. So when it contracts, pulls the radius towards the ulna, that's going to be a pronation. I'm going to take this model, I'm just going to turn it around so we can see it from another aspect. Pronator quadratus. Pretty straightforward on this one. All right. And we should be getting near the ends of our list today, you guys. We might be making pretty good time. Oh, my, wow, there's our list. So, all 8 of these muscles get muscle cards for next week. These are the muscles that we'll be drawing and working on each other in lab this week. We do have like 15 minutes left. So questions, guys, any questions? Seriously, anything you want me to show you on the app? Anything we want to re-examine?
Does supinator have actually 4 origins? Because it seems like there's a lot of origins for a very small muscle.
Mm-hmm. The deal with that is we are not really looking at the ligaments and the other things. So when it's looking at its origins, I think your trail guide is listing like annular ligaments and things like that as origins. So here is the supinator muscle, but we do see, oh, come on, thing. I think it's time for me to get a new iPad. This thing is getting real jumpy on me. But you see, it's not just the bones that it's attached to. It's also attached to that whole joint capsule around the elbow. And the annular ligament there, which like wraps around the head of the radius just to keep that thing locked in place as it rotates so it just doesn't go like roaming around. The muscle does have like anchors on there, right? The epimysium is fused with the outer layer of that ligament. So strictly speaking, yes, those points are used to anchor the muscle so that its insertion can move around. So that we do count those as origins. I know that they're not bony landmarks, but yes, they are counted. But the cool thing, guys, we finally got to bicep. So now we like know what our biceps do and our triceps. And brachialis, you can't forget about biceps' best friend, brachialis, right? If you really want your biceps to pop, you got to have brachialis well developed to really lift those guys up. We also talked about our beer drinking muscle, brachioradialis. There. And how to spot it, right? Flex against resistance to make this muscle arise on the top of your forearm. And you got to say it with a Scottish accent too. It's so much more fun when you say it with a Scottish accent. Biceps, triceps, brachialis, brachioradialis. We covered pronator, supinator, pronator quadratus, and anconeus. All solid muscles of the elbow. Come on, iPad. All right. So read the stuff that we covered today, reread all the stuff that you've learned before. These 8 muscle cards will be due next week. Open table, guys. Anything we want to talk about?
I wasn't here for last Thursday. Was the cards due last week the trunk muscles?
If I'm not mistaken, the trunk muscles were the ones that will be due this week. The ones
Oh,
that we checked were from week 4.
okay. Were the erector spinae all in one card?
One card, yes.
Okay. Okay.
Yeah, and I didn't want you guys to worry about like all the individual origins and because there's a lot.
Mm-hmm.
They're like each one of those muscles just has like an insane. I don't want you to
Yeah,
worry about those. Just focus on them as a group.
Yeah.
Yeah, one card. Yep.
Okay.
And just like as a group, what do? Like they extend the spine. That's what they do.
Okay. Thank you.
You were here for the lecture though, right? The I love
Yeah.
spaghetti. Put them in order.
Yeah.
Then you should be good. Yep, you should be fine. Good stuff. Yeah, I see lots of yawning. Yeah, I get it. I know. It's a rainy day. All right, guys. Well,
I have a question. I don't know if a silly question, but I'm thinking about it.
let's do it.
Okay. Till is kind of a movement, right? Like till head or till hips, right? Tilt.
Yes.
Okay. So my question is this movement has a synergist, like for example, quadratus lumborum and rectus abdominis? Is that okay if I say that?
Say that one more time for me.
They are synergists or till, or we don't say that. Tilt
If
movement.
they do the same
Like
thing,
anteriorly
Uh-huh.
and posteriorly tilt the hips.
Yeah, for example, I have the
so
quadratus
anterior,
lumborum and the rectus abdominis. These
yes,
two do the
yes,
same movement. They are
yes,
synergists, right?
correct, correct,
So I
yes,
can say that.
absolutely, yes, yes.
I wasn't sure. Okay.
So
Wait, aren't they on
we got,
different?
so we,
And
What?
we have
anterior and
antagonists of
posterior?
this. I'm confusing with this movement.
with pelvic tilt, that's specifically with pelvic tilt, okay.
Exactly. Yes.
Okay. When we see the hips and, oh geez. All right, so we've got the hips. An anterior pelvic tilt would be the hips rolling that way. Yeah,
Okay.
so with an anterior pelvic tilt,
Okay.
the quads are pulling down, so quads are shortened. And the lumbar area is shortened because those are pulling up on the back side. So we pull down on the front and up on the back, and the hips tilt forward.
Okay.
So abdominals are going to be lengthened.
Okay.
And hamstrings are going to be lengthened. So what you're asking is, when we see the lumbar muscles and the quadriceps are shortened when we do this action. So the action that they are performing is anterior tilt of the pelvis. They are doing the same action. So are they synergists? Yes, they are. Yes.
Okay, thank you. Okay, now.
So these guys are synergists for anterior pelvic tilt. Hamstrings and abdominal muscles will be synergists for posterior pelvic tilt. So when the abs contract, they pull up on the hips. Hamstrings grab in the back and pull down, so the hips roll backwards instead of rolling forwards. So the answer to your question is yes. I just want to make sure we understand why that is a yes.
Thank you. Okay, that clarified a lot. Thank you. It was like,
Yeah.
okay.
Yeah.
Okay.
So let's look at something else. I forget how to clear all my crap out of here all at once.
I think if you hit home, Dave, that usually does it. There's like a home, yeah, up at the top. I
There's
don't
also
know.
an undo.
Yeah, it
at the
puts
Or
top.
the
my
little arrow.
that never does it. It just keeps putting my crap back on.
Maybe just close out of it altogether.
That'll do it.
Yeah.
Okay. So let's take a simpler action like elbow flexion. right? Yeah, we are getting at the same thing. So bicep flexes, also brachialis flexes. So those are synergists for flexion. All these muscles that work together to do the thing, those are synergists. So you've got your prime mover, right? Your Batman, that's going to be bicep with no weight, no resistance, no nothing, just bend your elbow. Bicep can do that all by itself. It's strong enough. No, it doesn't need any help. But the second you start adding weight, right? Like when I grab my full cup of coffee, now the bicep may not be able to do it as much. Or more to the point, maybe we need other muscles to stabilize the movement, right? Because it's one thing to just flex the elbow. It's another thing to flex the elbow gracefully and controlled in a way that I can take a sip of my coffee and not jerk the cup all around, right? This is why toddlers can't, like, this is why toddlers need sippy cups, because the brain is still learning how to coordinate those muscle contractions. So with no other thing, just bend the elbow, bicep can do that by itself. But when we start needing more sophisticated movements, like actual like motor control over drinking or vaping or writing and things like that, now we need other muscles to contract. Those are your robins. Those are synergists, other muscles that will do the same action. They assist the prime mover. Now we've got one side set up. Now we have the joker. Now we have an antagonist muscle like triceps, which does the opposite action. Now Batman and the Joker are enemies, but with muscles, we're both working together for the same thing. We need the organism overall to move gracefully. So it's not a good guy versus a bad guy, right? The two are working together so that not only can I flex the elbow to take a sip of coffee, but I can also extend the elbow and put the coffee down on the table. Now, tricep just happens to be the only elbow extensor. It's the only muscle, you know, on the backside that assists with extension of the elbow. But if there were other muscles, that we would have the same story, right? Tricep is the prime mover, and then all of the other extensor muscles would be its synergists. It just happens to be that this example is the only one. Good stuff. I worry sometimes, guys, that I'm not explaining it clearly enough. I want to make sure everybody understands. I can explain a million different ways.
Thank you. No, your explanation is great. Yeah, thank you.
Good stuff. All right, guys. Well, that's where we are for today. If you come up with any questions while you're studying, write them down, bring them to me in class. I'm happy to explain this stuff, happy to go over it. It's my favorite part of the job. Otherwise, stay dry out there. It's looking very rainy. So stay inside and make some hot tea and enjoy your Monday.
Thank you.
I'll see you guys
Thanks,
Thursday.
Thank you.
Bye.
Bye-bye.
I had a question for you, Dave. Oh, did you already hop off? Oh,